All right, today we're talking about absolute value equations. And before we talk about absolute value equations, we need to just take a step back and think about what is absolute value. And what is absolute value? It's positive, okay. Yes, in a general sense, in a specific sense. Like, what do you got for me? How far it is away from zero, or are you going to say the same thing, distance from zero? All right. Okay, so when we went and took the absolute value of, say, 17, that was maybe 17. 17. Yeah, there you go. And if we went to take the absolute value of negative 84, what was that? Positive 84, yeah. Okay, so in general, we could define the absolute value of a number. We could define it as, well, if it's positive, like this one here, absolute value didn't do anything to it. It's just the same as the number on the inside. And if it was negative, we took the negative away, which is the same thing as multiplying by negative 1. So it's like negative x if x is negative. Okay, so we're going to start with, like, the most basic of absolute value equations. Absolute value of x equals 5. What kind of x would make this equation true? 5 for sure, right? Is there anything else? Yes, negative 5. Okay, so, you see I highlighted that. This is so important to what we're doing today. All of the equations that we're going to solve today are going to come back to this example, basically. We get the absolute value of a thing equals a number. It's either going to equal that number, or it's going to equal the negative of that number. Okay, so over in the next one, you see the absolute value of x plus 2 equals 7. Well, if you just think, what do I have to add to 2 to get 7? Well, that thing I circled in red is going to need to be 5. So I'm going to say absolute value of x is equal to 5. And when we just did that, that means that either x is 5, or it could be negative 5. Yes, 888. There you go. Okay, now you could subtract 2 from both sides, because that's what we've been doing. But, sometimes just looking at it, you see that something needs to, the thing needs to equal 5. So the absolute value equals 5 when x is 5 or when x is negative 5. So we've got a strategy to solve these. First, we're going to isolate the absolute value. So we're going to get it down to absolute value of a thing is equal to a number. This is the most important step. And then once we get the absolute value isolated, we're going to say either the thing inside is equal to the number we see, or it's equal to the negative of the number that we see. Now, there might be a third case, but we'll look at that a little bit later. And then the last step is solve for x, or solve for the variable we're interested in. But at this point, that's pretty much just instinct. Okay, so we'll start, putting this into action. So first, we're going to isolate the absolute value. So we're going to try to get this absolute value of x by itself. So I'm going to start by subtracting 2. So I have 3 absolute values of x equals 15. Then I'm going to divide both sides by 3. Okay, and it's like, oh, man, again, absolute value of x equals 5. What could x be? It could be 5. Or maybe it could be negative 5. Okay, this one over here on the right, we've got an absolute value in the denominator of a fraction. What are we going to do? Okay, I would recommend taking this 4 and calling it 4 over 1. Then what does this thing look like I should do with it? Yeah, cross multiply. Last period they called it the butterfly. I don't know really where that came from, but yeah, we're going to cross multiply. So I'm going to have 2 times 1 is equal to 4 times absolute value of x minus 3. Okay, so I've got 2 equals, I'm going to distribute here, 4 absolute values of x minus 12. I'm going to add 12 to both sides. I'm going to divide by 4. Okay, and now finally I have something that's not absolute value x equals 5. And say, well, either the thing on the inside could be 14/4, right? Or maybe it could be negative 14/4, right? And the equation would still be true. Okay. So that's how we're getting two equations to these, or two solutions to these equations. Okay, now looking at these next four, the question is, if I look at, this one and that one, do we solve these the same way? And, I mean, you could say, no, you don't just, you can't just add one out of here. That doesn't work. But we are going to solve them the same way in the sense that we're going to follow the same strategy. We're going to isolate the absolute value. We're going to make some sort of analysis, and then we're going to solve for our variable. Okay, so over here, I'm going to isolate the absolute value, and I get an absolute value x equals 5. You're like, oh, no, not absolute value x equals 5 again. Like, I get it. It means that x is 5 or x equals negative 5. Okay, I understand. Hopefully, on the quiz next time, when you see absolute value x equals 5, we all get that one right. I would expect that. This one, on the other hand, okay, so I've got something interesting going on inside of the absolute value. So what I think is, this thing here that I've, kind of underlined with red squiggly lines, that thing needs to equal 4, or maybe that thing could equal negative 4. And then you replace that with x minus 1. And now I'm going to solve for x. I'm going to add 1 to both sides. So I'm going to say x equals 5, or maybe x equals negative 4, add 1 back is negative 3. Okay, so I'm going to let you try this one on your own. Okay, so I'm going to freeze the screen, and if you're watching on the internet, I'd recommend you pause the video here in a second, and then check your answers against mine. Okay, so there we see we've got some answers. Is that what we were seeing? Yes, I'm seeing some people with the right answer. Yes, good for you. Wonderful. Yes, lovely. You have one of the answers. Okay, that's decent. Could be better. All right, and if you're curious about how I got that, here's the work that goes with it. So right, we isolate the absolute value on the left. That's going to take a little bit of work. It's going to take 2 steps on the left. On the right, it already was absolute value thing equals number. Okay, and then we, carry out the analysis, solve for the variable, and we get a solution. Okay, next we got a couple where looks like the variable is multiplied by a negative number, and it's like, oh, is that going to change anything? I'll tell you it won't. But if we're ever unsure, I can also give you a strategy to help, maybe deal with that uncertainty. So in the other classes, I did the one on the left, so I'm going to work the one on the right now. So I'm going to say, okay, absolute value of a thing equals 9 when either that thing equals 9 or maybe when that thing equals negative 9. All right, and now I'm going to subtract 3 from both sides of both equations. I'm getting y equals 3 and y equals negative 6 divided by 4. Okay, and so if you're unsure of, maybe this negative, made the solution bad or something, what you could do, you could always go and check your answer. So the absolute value of negative 4 times negative 6 over 4 plus 3 is going to be, well, that's the absolute value of positive 24 over 4 is positive 6 plus 3 is, that's equal to 9. Okay, so good. Absolute value is equal to 9. What about 3? absolute value of negative 4 times 3 plus 3. Okay, I'm seeing negative 12 plus 3 is the absolute value of negative 9, which is equal to 9. Okay, so both of them worked. It was all right. Okay, maybe we've got, a fraction inside the absolute values. How are we going to deal with that? Okay, well, I'm going to start with, if an absolute value of a fraction equals 2, then that fraction is probably going to either equal 2 or negative 2. And what I'm going to do is I'm going to cross multiply again. Okay, so I've got 4 times 2 is 8 is equal to 1 times 3x minus 1. Or I've got 4 times negative 2 is negative 8 is equal to 1 times 3x minus 1. All right, what I'm going to do is I'm going to add 1 to both sides, and I'm going to have 9 is equal to 3 times x. Over here, I'm adding 1 to both sides, and I get negative 7 is equal to 3 times x. Then when I solve for x, I'll get x equals 3, and x is equal to negative 7/3. All right. I want you to try the one on the right. 10 over x minus 2, absolute value equals 2. All right, give that one a shot. Make sure you're doing it right, but it seems like so far we're doing pretty good. All right, so there you go. You can see I got answers of negative 3 and 7. And if you're interested in seeing how I got that, I'll put the work up right now. Okay. Say probably the thing that would be most likely to derail you from getting the right answer would be that step where we have to distribute the 2, or especially the negative 2. I know that, that's a place where we can sometimes trip up. But overall, I just suggest, right now we're saying absolute value of a thing equals 2, that thing equals 2, or that thing equals negative 2. Cross multiply, solve it out, and this is something that we can do. All right, next. We got absolute value of x equals negative 2. What kind of x's could I take the absolute value of and get a negative number? No, yeah, that's not going to happen. That's not possible. Imaginary, not even imaginary numbers. We'll talk more about that, a little later on in the year, but the absolute value of an imaginary number is always positive as well. Yeah, we'll actually call those complex numbers in general, but, plenty of time for that later in I think it might actually be later this semester. Okay, so we see absolute value equals negative number. We're thinking that's not possible. And we conclude that there is no solution. Okay. Over here, this one, I'm going to, observe our set of steps, and I'm going to isolate the absolute value. So I'm going to subtract 7 from both sides, and I'll have absolute value of 2x plus 5 is equal to 3 minus 7 is negative 4. And then I'm saying, oh no, I've got an absolute value of a thing equal to a negative number. That isn't going to happen. So I'm going to stop right here, and I'm going to conclude that there is no solution. There is no value of x that's going to make that equation true. Okay, I've got another special case here. We got 3 times the absolute value of y minus 4 plus 5 is equal to 15. Well, okay, I think, there's a couple of ways that we could proceed. I feel like y'all would be most likely to attempt to distribute this first. So I'm going to do that. I'm going to say 3 absolute values of y minus 4 plus 15 is equal to 15. I'm going to subtract 15 from both sides, and I'll get 3 absolute value of y minus 4 is equal to 0. Oh no, lost 5 there. Oh goodness, there it happened. Oh man. Okay, not sure what happened there, but now we've got 3 absolute value of y minus 4 equals 0, and we're going to divide both sides by 3, and I get absolute value of y minus 4 is equal to 0. And how can I get absolute value of a number equal to 0? Yeah, if it's 0. Is there anything else that I could take the absolute value of and get 0? I don't think so. There's nothing else that's 0 away from 0 on the number line. So I'm going to say that that means that y minus 4 equals 0. And just 0, no other numbers. So I'm going to add 4 to both sides and conclude that y equals 4. Okay, now another question. Can I just see an absolute value equation, see it's equal to a negative number, and just conclude, oh, no solution? No, you can't. Okay, you have to solve, you have to isolate the absolute value first before we, go into that analysis of absolute value of a thing equals 9 means it equals 9 or negative 9. Absolute value of a thing equals negative 10, no solution. Okay. So what I'm going to do is I'm going to subtract 10 from both sides. I'm going to have negative 2 times the absolute value of x minus 3 is equal to negative 14. And then I'm going to divide both sides by negative 2. I'll have this absolute value of x minus 3 is equal to 7. Okay, and if the absolute value of a thing equals 7, then that thing is either equal to 7 or maybe it's equal to negative 7. I'm going to add 3 to both sides of both equations. And then I'm going to get x is 10 or maybe x is negative 4. Right? So just because we see this, it's negative 4, it doesn't mean that we can just throw our hands up and say, no solution, I'm done. It takes a little more analysis than that. All right, now what are we going to do if we have absolute value on both sides of an equation? That's an interesting question. So I'm going to just, go at this in terms of numbers for now. I've got absolute value of a number A is equal to the absolute value of a number B. It could definitely be the case that A equals B, right? If two numbers are equal, they have the same absolute value. So like absolute value of 7 is equal to the absolute value of 7. But there's another way that these numbers could be equal, right? Because the absolute value of 7 is equal to the absolute value of negative 7 as well. So A and B could be opposites. So over here, if I've got these two things are equal in absolute value, then either 3x minus 1 is equal to x plus 5, or maybe 3x minus 1 is equal to the negative of x plus 5. And then I'm going to, kind of take these out. I'm going to subtract x from both sides on the left equation. So I'll have 2x minus 1 equals 5. I'll add 1. I'll divide by 2. And I'll get x equals 3. Over here, I need to distribute the negative to both things. So I'll get 3x minus 1 is negative x minus 5. So now I'm adding an x to both sides. I'm adding 1. And then I'm going to divide by 4. All right, any questions on this? There's usually a question here. Okay, so the question was, why didn't I just multiply 3x minus 1 by negative 1 as well? And so you could have multiplied 3x minus 1 by the negative 1. But if you had, you would have needed to have kept x plus 5 the same. Because if we multiply both of them by negative 1, what we're really doing is we're just reconsidering the case where they're exactly the same. Because if we multiply both of them by negative 1, we're basically looking at the case where negative 7 has the same absolute value as negative 7. Okay, so we wouldn't be getting anything else. If we made both of them negative, we would have gotten x equals 3 with probably, an extra step of distributing negative signs. All right, so let's, put this one into action again. So I'm going to say, okay, I've got the two absolute values isolated. They're either going to be exactly the same or they're going to be exact opposites. So I've got this 2x minus 3 is equal to 5 minus 2x. Or maybe 5 minus, 2x minus 3 is equal to the negative of 5 minus 2x. And I'm going to add 2x to both sides, and I'll have 4x minus 3 equals 5. for x equals 8 and x equals 2. Or, okay, I'm going to distribute the negative sign. I'll have 2x minus 3 is equal to negative 5 plus 2x. I'll subtract 2x from both sides, and I'll get 0 minus 3 equals negative 5. Negative 3 equals negative 5. That's not good. Okay, that's not yielding a solution. But does that mean that we can just say that the whole equation has no solution? Like, what do we really want to do with this? Okay, I'm going to go back, and I'm going to check the answer I do have against the original equation and see if it's actually a solution. I'm going to check x equals negative 2. Right, so I'm going to have absolute value of 2 times 2 is 4 minus 3. It's equal to the absolute value of 5 minus 2 times 2 is 4. So I have absolute value of 1 equals absolute value of 1. It does work. Okay, so what this means is that, okay, yes, this equation does have no solution, but it means that this case here is not contributing an answer to our overall solution. So x equals 2 is the only solution. And if you're interested in this, what you might want to do is you might want to just like graph the function y equals 2x minus 3 absolute valued, and then also at the same time graph y equals the absolute value of 5 minus 2x. What you'll find is that basically, I'm just going to draw that in black. You get two v's, and we're going to talk about the graphs of absolute value functions a couple of times from now. And then the other one would kind of come through, it would be almost parallel in a sense, and so they would only intersect one place, and that would be the place where x is equal to 2. But you don't got to worry about that for now. Alright, the last example I've got for you is this one, and I'm going to have you work on this one on your own. I'm going to walk around and check and see if you're doing it right. If you're watching this at home, you know you might want to pause the video here in a few seconds and then check your answer against mine. Okay, so there you can see the answer, and there you can see the work. If you got any questions about this, I guess, come in and see me in the morning or sometime, or stop by after school, stop by after lunch sometime, and I can help you with it, because this is something that we can all do for sure.